Welcome everybody. Today's lesson is on domain and range by looking at the graph of a function, and we're also going to talk about function notation. Well, our first graph, we have the function f of x equals x squared minus 2. So what's the domain and range of this? Well, first of all, what is domain? Domain is your x values. That's the numbers that you can input into the function. So what values are you allowed to input into a function would be your domain, and then your range is your y values. That's your output, the answer you get. When you input the x, what is your output? That's your y value. Notice the y has that straight line down. Well, that matches up with the y-axis. Notice the y-axis is vertical, stem of the y is vertical. Help you remember that. And then the x-axis is your horizontal axis. Now as we go through this, feel free to stop this and pause this video any time and write in the answer. So what is the domain for this function? The domain would be your x values. What x's are you allowed to input into this function? Can you input a 0? Well, when x is 0, there's your output. You get a y value. When x is 1, there's your answer. When x is 2, there's your answer. Here x is 3 right there. And look at, you have an output. It would be somewhere up here. When you have x equals 4, 4 squared is 16, 6 minus 2, be 14, be somewhere up there. When x is 5, get 25 minus 2. For every x, there's going to be an output. So the domain then, and I'm going to put this in interval notation, goes from negative infinity to infinity. You can use any x you want. So when x is negative 2, there's your answer. When x is negative 3, again your answer is going to be up there somewhere. Notice when we use the interval notation with parentheses, you always, with infinity, you always use parentheses because you can never equal infinity. If you have an equal, then you use the bracket, and that's what's going to happen in the range. The range is your y values. Are all y's being used? No. Stop right here. Your y values. Right down there. So what is the range? The range can equal to, negative 2, right? That's the lowest y value you can get. When you input a 0, you get 0 squared minus 2, which is negative 2. Anytime you square a number, it's going to be positive unless it's 0 squared. So there's no way you're going to get a value less than negative 2 because this is always going to be positive or 0. So negative 2 is the smallest value for y, and then you can see your y values just keep going up from there. So it's negative 2 to infinity. So notice the bracket because it can equal negative 2, and the parentheses because it goes on. It's unbounded. Okay, well now let's look at function notation. Notice we have f of x over here. Well, f of x, there's 3 parts of this. It's 3 in 1. You have your x right there. That's your input. So inside the parentheses is input. And then this f right here, that just names the function. That just gives it this name. You can use any letter you want. We use f a lot of times because function starts with f. And then the whole thing, this whole thing right there, that's your output. That equals your y value. So 3 parts. The inside is your input, that's your x. The f names it, and then the whole thing together, f of x, that is your output. If we start with f of 0, what am I doing? I'm inputting a 0 in for x. So you could actually just look at the formula, right? Input a 0 for x right here. So you put a 0 right here. 0 squared minus 2 is negative 2. You can just get it right off the formula. But let's get it off the graph. That's what we want to work on this one. We're featuring from the graph. So when x is 0, there's your y value down here. Y is at negative 2. How about f of 1? Right here. f of 1, the output is negative 1. How about f of negative 1? When x is negative 1, what's your output? Negative 1. Right. Very good. When x is 2, so I have f of 2. What's my output? Right there. I don't know why I'm putting parentheses on those. 2. And what is f of negative 2? Right here. When x is negative 2, y is up there. Y is 2. Okay, let's look at another graph. We're going to label this graph C. Now notice we don't have a formula, so we have to get all our information from the graph. You can go ahead and pause it and then answer both these. So my domain is my x values. My x values are going across. It starts here and goes to there. So all these x's from negative 3 all the way across. I can use x equals negative 2.9, x equals negative 2.1, x equals negative 2. There's my y value down there. Looks like 1 1/4 or something like that. That's your x-intercept. You can use all the x's from negative 3 to 4. And then the range would be the vertical. Notice it's all the way down here at negative 4. Okay, it bottoms out at negative 4. Where does it top out? Right there, which is 4. So that's my range. Now let's look at function notation. What is C of 0? So if you input a 0, what's your output? How about C at 4? 1, 2, 3, 4. When x is 4, y is 1. How about C of negative 3? When x is negative 3, 1, 2, 3, y is negative 4. Okay, let's skip down to the next graph down here, P. This is function P. So what's the domain? The x's go from here, negative 5, all the way to 2. So all the x's across going this way. Negative 5 all the way over to 2. And then your range is your y values, so that's on the vertical. So it's down here. And there's your peak up there. So the range goes from negative 3 all the way up to 5. And that would be a bracket also. Now let's look at function notation. Okay, I did this a little bit different. So I want you to know find x. Up here we are finding the y values, function notation. Now we're given p of x equals 5. What x value gives you 5? And the other one's p of x equals negative 3. So pause it, figure it out. Welcome back. Okay, p of x equals 5. Well, that's right where the arrow is. And it's 2. When x is 2, go over to 2 right there. And your output is 5. So p of 2 equals 5. So what x value gives you? X gives you negative 3. Right there's negative 3. And right there, negative 2. So p of negative 2 equals negative 3. Let's go back to what we were doing before. Let's do p of negative 4. What's your answer? P of negative 4. 1, 2, 3, 4. And there's your y. It's at negative 1. And one last one. We'll do p of 1. When x is 1, what's your output? Here's 1. Your output is right there on the graph, so it's 2. Okay, moving right along. Here you go. This is a constant function. What's the domain of that? Well, the domain again is your x values. Notice it goes all the way from left to right. So the domain would be negative infinity to infinity. Any x value works. And what's the y? What's the range? Which is your y values. It's a constant function. Y is always going to be 2. So the equation of a horizontal line is always y equals. What's the y value? Y equals 2. So we could do the same thing. We could say c of 0. What's that going to equal? 2. C of 3.5. What's that equal? Well, 3.5 is right there. Your output's going to be 2. What is C of pi? Where's pi? 3.14, right in there. It's 2. What's C of 358,000? 0.2. It's 2. Your output's always 2. How about the function below? Wait a second. That's not a function, right? Fails the vertical line test. And so does this one over here. These are not functions because they fail the vertical line test. But let's go ahead and look at the graphs anyway. They still have x's and y's in them, right? So let's look at this. It's not a function. What's the domain? What x values are you using? Well, there's only one x value. X equals -1. And look at there, you get the equation of a vertical line. The equation of a vertical line is always x equals, and what's that x value? X equals -1. And notice the range, the y values, it's a vertical line with arrowheads on it, so the range goes from -infinity to infinity. And this one right here, the x values go from here to there, so domain goes from -2 to 2. And the range goes from -3 to 3. So that's just a little bit on graphing and being able to get the domain and the range from the graph, and a little bit about function notation. Thanks for watching the video. See you on the next one.